Hello everyone. Welcome to the introduction session on advanced embedded systems. My name is Rohit Sanal. I'm an embedded engineer with 13 years of experience in firmware development and technical trainings. I have trained over 1,000 engineers on firmware programming. I began my career in R&D back in 2010, and I have designed over 60 embedded projects, and I've also been part of R&D teams which has worked on 5 commercial products. In 2015, I've moved to Dubai, working with a leading German brand of automatic doors as its product specialist for automation and connectivity. So in today's session, we are going to see what advanced embedded systems are. We are going to discuss how is it different from a developer's point of view. We are going to see what is the role the Linux operating system plays in the embedded domain and what are the various verticals of embedded systems. We are going to see how big is the opportunity, and we are also going to understand how big is the opportunity for us. What is required for us to land a job as an embedded engineer? And we are also going to discuss what our particular course is going to cover. So moving into the course. So what is the advanced embedded systems training and who is it for? So this course is designed for graduates and working professionals who it is focused basically for the current requirement and the upcoming requirement of the embedded industry. It covers hands-on training experience and it provides a basics to approach advanced approach. We ensure that you have the necessary knowledge not only to crack the interview but also to perform your daily tasks as an embedded software developer. So the question comes in, advanced embedded systems. Why advanced? And what do you mean by advanced? So, in simple words, when we talk about embedded systems, the definition of an embedded system is a special purpose computational system which is having a customized hardware and a customized software, which generally we call as firmware. However, there has been a lot of advancement in the embedded technology. You would have heard of Moore's law, that every year the size of the semiconductor device increases by double, or the amount of transistors which can be the amount of transistors which you can have on a single chip would be doubled. In either case, the computational power of an embedded system has increased dynamically. Based on the complexity of the system, embedded systems today are classified as basic embedded systems and advanced embedded systems. So let us get an overview of what these two classification is based on. However, there is no hard and fast rule saying that from this point it is an advanced embedded system or this is a basic, but this is a broader understanding of the industry, and we are going to take a certain features which a basic embedded system has. So when we talk about basic embedded systems, generally it is a simple loop control embedded system. That means there is one or two loops in which a repeated activity is performed by the embedded system. It is interrupt control system. That means the device has the capability of behaving in a certain way when a certain interrupt or an event is occurred. It also has the capability of providing something called as cooperative multitasking. Cooperative multitasking basically means that the system has the capability of doing two, three different tasks, but only one task at any given point of time. So that is called cooperative multitasking. And generally, these systems are designed around 8-bit or 16-bit microcontrollers. So you would have heard of a lot of microcontrollers like the 8051 series, the AVR series. These are all microcontrollers which come in the category of 8-bit microcontrollers or 16-bit microcontrollers. As we move forward into more advanced architectures, The concepts which we come across are something like preemptive multitasking or multi-threading. This is basically when the system has the capability of running multiple processes at the same time. It is not one task at a time, it has the capability of executing hundreds of instructions or hundreds of processes simultaneously. We also come across full-fledged operating system. The examples you would have heard of Linux operating system or Android-based systems. These are generally run on the hardware which is designed around 32-bit or 62-bit, 64-bit microprocessors. They are also classified on the basis of their design as single core or multi-core architectures. They come under the category of system on chip devices or system on module devices or single board computers. So these are more technical terms where you would have heard of Raspberry Pi or BeagleBone Black. These comes under as a single board computer. Basically, you have a board on which the entire computation or the entire computer is designed. As I have told you, the classification is not hard and fast. So it is not defined by the physical size of the board. That means if the board is big or small, it does not directly say that a basic embedded system has a small board or a big board. It is not dependent on the number of I/O pins. It is not whether you have 30 pins or 40 pins. But what actually classifies an advanced embedded system is the computational power. When we talk about the computational power, the two main things which comes into picture is the clock frequency. So you will see that boards like Raspberry Pi as well as BeagleBone Black, they operate on frequencies, on clock frequencies around 1 gigahertz and higher. Whereas your traditional microcontroller based designs, they work on megahertz frequencies. So the amount of computational power these devices are able to generate requires a more advanced way of interacting or designing the system. So how is it different for us as developers? What is the significance? What difference does it make whether it is a basic embedded system or whether it is an advanced embedded system? How is it different from a developer's point of view? So from a developer's point of view, the most significant difference which we see is the presence of an operating system. Because these hardwares, which we call as advanced embedded systems, have so much computational power and they have the ability of running hundreds of instructions or hundreds of processes at the same time. If these resources are not properly distributed and not properly allocated between all the processes, then it is a wastage of those resources. Therefore, in order to effectively distribute and effectively manage the resources of your hardware, there is a specialized software called as the operating system, also known as kernel, which acts as the interface between the user space applications and the hardware resources. So this is the most important or the most significant difference which you will see as a developer between a basic embedded device and an advanced embedded device. So why do we need to focus on advanced embedded systems? Why not the basic? In 2023 and moving forward, all the upcoming opportunities which we see in the market are for advanced embedded systems. Basic embedded systems is the history, it is the past, it is what was running the market 10 years ago. But today and in the coming future, the advanced embedded systems is the only way moving forward. The reason explosion in IoT devices, smart devices, Even the smallest of embedded devices like a smartwatch or any kind of the utility which you call as smart, let it be a smart refrigerator, a smart air conditioner, everything requires to connect with some kind of a cloud application. Everything requires to use the internet. Therefore, some kind of an operating system is required to manage the complex architecture. This directly puts all these devices in the category of advanced embedded systems. So this is not possible with the basic embedded system, which we also call as bare metal programming. When there is no operating system in between the hardware and the application, it is called as bare metal programming. Currently, because of the explosion of smart devices and IoT devices, almost every device requires to have an operating system. So the all the opportunities we see in the market today are purely on advanced embedded systems. So let's come to the next part of our session. Let's understand what is the role of Linux operating system and what are the various verticals of the industry, of the embedded systems industry. So throughout this presentation, we will see or we will have a deeper view or deeper understanding of various verticals in which embedded devices are used. Generally, when we think of an embedded devices, we are only thinking about the industrial use, like a factory, or we are looking at some kind of a mobile device. But in this session, I want you to understand what are the other verticals where all embedded systems is playing a crucial and important role in driving the society today. Imagine for a second a world where your smart devices, appliances, vehicles are all intelligently connected and enhance your experience as a user experience. We are in that world today, and the embedded systems are is the backbone of technological advancement. All your smart devices, all your connected information driven systems are all powered by embedded systems. Let's look at some of these in detail. Let's start at home about things which we all know: consumer electronics. Have you heard of web operating system, Tizen operating system, and Android operating system, or Android TV? These are the operating systems used in smart TVs. But I'm sure you have not heard of these operating systems because you know them by their brand names. So the operating system which LG uses in its smart TV is called as web operating system. The operating system which Samsung uses is called as Tizen operating system. And other brands which make smart TV use a special version of Android which is tailored for smart TVs called as Android TV operating system. But we're discussing about Linux, right? Yes. All these operating systems are versions of Linux. So if you just go to YouTube or Google, or if you go to Wikipedia and search for these operating systems, you will see that these are Linux based operating system. And you will see one more word, that these are Unix like operating system. Both of these words mean exactly the same thing, that they use a kernel which is based around the Linux architecture. So they are just different versions of Linux. Even Android, which we all use in our phones, is nothing but a version of Linux. So although we don't directly see Linux, everyone in today's society uses Linux directly or indirectly. Let's take another example about something which we all have in our homes, but we never think that this is a Linux system. Routers. Everyone has Wi-Fi in their house. They have a Wi-Fi router. The routers internally has an operating system called OpenWRT. It is a popular open source operating system and it is used by companies like Linksys and Netgear. When do you see this? When you try to configure your router, you just log into its default IP address. The interface, the user interface which you see is the operating system. This operating system is a version of Linux which is tailored specifically for the needs of being a router in order to implement the connectivity protocols. What else? Let's take a look at telecommunication. We have tablets, we have smart speakers, we have mobile phones. The entire industry of your smartphones generally uses either Android or iOS. Both of these are internally a version of Linux kernel, which is tailored for mobile connectivity. You have your smart assistants like Google Home, like Amazon Fire. You have the Siri application. All these run on dedicated OS. The Amazon runs the Fire operating system. The Apple runs the audio operating system. Similarly, you have these are also when you see the word Unix like operating system or Linux operating system, it means the same. You have modems and gateways. So you have companies like uh, Huawei and Cisco who use a version of Linux in order for their application. Let's go a little bit more into detail. Let's take a look at some other industries which we generally don't think about as embedded systems. The field of medicine. Embedded systems are revolutionizing healthcare. From patient monitoring systems from companies like Philips and GE to your simple smartwatch, which most people use in order to track their fitness and their activity. These are running on embedded systems. They are running on some kind of an operating system, which is based on the Linux kernel. The defense and aerospace industry. All your military communications, all your satellite navigations, all your avionics, which is basically how the flights get their information about traveling. These are based on different versions of Linux. So you have companies like Wind River, which makes operating systems called VxWorks. You have companies like BlackBerry making QNX operating system. You have different companies which are making different versions of Linux. But why are they making different versions of Linux? Because Linux is an operating system which can be customized. That means when you are talking about something like automotive industry, there are certain specific features the automotive industry requires. For example, you have the advanced driver assistance system. ADAS is something which is very specific for the automotive industry. You don't need this feature inside the medical industry. So the Linux operating system gives the user the capability of customizing the operating system. This is why it is the go-to and the preferred operating system for every industry which is into embedded systems. What else? Let's take some more examples. Industrial automation. Most of your factories and productions are run by PLCs. So you have companies like Siemens, Rockwell Automation, Schneider. They run their PLCs using operating systems which are again developed around the Linux environment. You have complicated HMIs, human machine interface, which require again an operating system for interfacing or connecting with the human beings. You have robotic automation. So in industrial production, in automated activities, you have companies like ABB, you have Universal Robots. All of them utilize directly or indirectly a version of Linux, which is the backbone of their entire infrastructure. Coming back to home with our smart home automation, you have things like Google Nest, Amazon Ring, you have the Philips smart bulbs, you have the security systems, because nowadays your CCTV is not just a camera, it is part of a larger system which is capable of providing peripheral security. Basically, all the cameras share information and they work on a data model. Again, this requires a operating system to manage the resources more efficiently. What else? Transportation, public transportation, your metros and your railway infrastructure depends on Linux-based operating system in order to pass the information reliably. You have intelligent traffic management system. So when you are at the signal, sometimes you are able to see on top of the signal something called as ATS, which is automated traffic system. So those are the systems which are managing the traffic lights. Fleet management. Companies like Ola and Uber, they have to manage thousands of vehicles. That is managed by an operating system. We have the energy and utilities. So you have the water, you have the electricity, you have the sewage management. All these systems are automated. All these systems now utilize some kind of an embedded device which is responsible for automatically maintaining the infrastructure. And these devices require an operating system to support their architecture. Agriculture, being an agriculturally dominant country, we have the utilization of embedded devices in precision farming, irrigation control, livestock monitoring. What else? Embedded systems are revolutionizing banking and finance. Point of sales. Now you have seen Paytm and you have seen PhonePe. All these payment gateways now provide a small unit which the vendor can have or the shopkeeper can have. So as soon as you scan the QR code, it gives the notification that it has received your amount. So all these are part of the embedded infrastructure. You have smart payment methods like your Apple Watch, again part of the embedded infrastructure. Coming to the retail industry. In retail industry, you have concepts like inventory management, smart shelf labeling, and digital signage systems. Everything is again part of a connected infrastructure which requires an embedded operating system. The educational industry, the way we are having a conversation today, we are using a Zoom call. This requires some kind of an operating system to run the server. You have smart technologies, you have learning management systems, you have Canvas and Blackboard. So basically, when I'm teaching you something, I can directly write on the board. So you have systems which allows me to interact and exchange information remotely. You can respond to us using chats. This kind of a two-way communication is facilitated by resource management of an embedded system in the background. The entertainment industry. The entertainment industry consists of your PlayStations, Xbox. You have your streaming devices like your Amazon Fire. You have the Android TV. You get all your Netflix. You get your Amazon Prime. All these things are streamed onto a device, which is then shared onto your TV. You have the concept of virtual reality with the invention of your VR goggles. Now you come into the scope of virtual reality and augmented reality. So it is more than just the industry. The concept of embedded industry or embedded systems today touch every industry. So in every industry and every domain, there are players who are into embedded systems because automation and connectivity has become part and parcel of our society in the 21st century. So I believe now you have a wider array understanding of all the companies to which we can cater to, or all the industries to which an embedded engineer can potentially look for building his career. Now let us understand some concepts about how big is the opportunity. Why now? Why now in the domain of embedded systems? How big is the opportunity? So after this session, what I want you all to do is to go and Google the word embedded systems market size. Embedded systems market size, and you will see the latest numbers in the market. These are the forecast of CAGR, which stands for Compound Annual Growth Rate. This is the industry which is growing the fastest in the market. Out of all the industries in the world, the embedded industry is the industry which is growing the maximum. So you will see that the global semiconductor market is expected to reach 990 billion by 2030. So semiconductor industry is the parent industry of embedded systems. So you have two broader classifications in semiconductor industry. One is the VLSI or the chip design part of the industry, and the second one is the embedded industry or the embedded systems industry, where you utilize the chips and make products which the industry is consuming. Automotive itself, the industry of smart cars, the evolution of cars from a pure mechanical device into a smart electric cars. The potential of the market currently is 132 billion. This is 2023. This year's market is expected to be 132 billion. This is the market of embedded industry. Now, how big is the opportunity for us? Why us, and why are we talking about this here in India? Because almost every semiconductor company in the world has its second largest operation here in Hyderabad. This is after the headquarters, the second largest manpower, the second largest workload being distributed or deployed here in Hyderabad. Our students have been hired in top MNCs in Hyderabad and all over India from these MNCs. So the big question comes in, what do you require to become an embedded software engineer? What is required for a person to be eligible to become an embedded engineer? So to land an entry level job into the domain of embedded systems, you need the following. You need to have a deep understanding of how to design and implement softwares using C programming. You need to understand assemblers, you need to understand libraries, debuggers, and simulators. You need to understand peripherals, compilers, version control systems, editors, and code writers. You need to have the ability of understanding hardware and reading schematics. You need to master Linux system programming, and you need to implement kernel and device driver programming. Of these, I need to bring your attention to C programming and Linux system and kernel programming. Why is it important? Irrespective of what information or what experience you have and how much background you have in the subject, with 1 year experience, no experience, or 10 years experience in the embedded domain, you will be evaluated first and primarily on your C programming skills. This is the mandatory requirement for a person to become an embedded firmware engineer. After that, you need to have Linux system programming and Linux kernel programming. This is what classifies between a basic embedded systems and an advanced embedded systems developer. Okay, so we'll have a deeper view or understanding of why this is in a minute. So about the course, what makes this course special? There are three ingredients which makes this course very special. First is the course content. The course is designed from a basics to advanced approach with complete transparency and hands-on lab experience. So when you go through the entire course content, you will see in how detailed we have covered every topic. The second and the most important strength of our course is the faculty. You have myself and two other faculty. We are from the industry, we understand the requirement of the industry, and we have experience in mentoring freshers and professionals. We have experience in grooming upcoming engineers to become senior level engineers. Placement, we have long-term tie-ups with various industries where our alumni have been working. You have a higher opportunity to crack the MNC interviews because you are trained on the core topics. So you not only have the opportunity of cracking the interview, you also have the capability, you will also have the knowledge required to excel at your job. Now, let's talk about in depth. What is how we are going to approach this course? We said we are going to start with C programming. Why we start from C programming is because in our experience, what we see as an academic C programming, which most engineers have, most graduates have, is not designed to meet the requirement of embedded software engineer. It is like you have application development and you have firmware development. So the general academic C program does not go deep into the C program. In this course, we cover advanced C, focused on concepts required for an embedded programming engineer. Once you have mastered the foundation, then we go into Linux system programming. It is very important to understand that when you talk about Linux system programming, we are not talking about just writing a few commands. We are talking about understanding and modifying the entire architecture of the operating system. We start by understanding the fundamentals of the operating system and the complex multiprocessor synchronization. Then we go into kernel and device driver programming. We will be implementing hands-on operating system porting onto boards like Raspberry Pi and BeagleBoard. We will be debugging the software issues using GDB, LTrace, strace, and other trace mechanisms. We will be doing some hardware debugging using JTAG. Coming to our faculty, as I've said, you have myself and two other faculty currently. Each person is an experienced professional who is currently working in an MNC. Combined, we have around 50 years of industrial experience. We have experience in designing and developing various IoT devices and embedded systems. We will be covering processor architecture like ARM processor. We will be covering OS concepts. We will be covering in-depth Linux system programming. kernel and device driver programming, and advanced topics like board bring up and OS porting. So just an overview, these are the course modules. When you attend the classes, we do not restrict you from just to go in the sequential order. We, in fact, encourage you to attend multiple batches at the same time so that you get familiarized with the lingo. So during the when you are attending C programming, we also recommend that you make time to attend Linux system programming so you can get used to understanding how C programming is used in system programming, how system programming concepts come into picture into device drivers. So you get the opportunity of attending multiple batches at the same time. You get multiple exposure. You will be able to work on hands-on boards like Raspberry Pi and BeagleBoard. We will be teaching you socket programming using protocols like TCP and UDP. We will be teaching you how to use protocols like Wi-Fi and BLE. We will be showing you how to use wired protocols like TCP, like I2C, UART, and SPI. So this is an in-depth course for an embedded engineer. So that's it for today, guys. Thank you all for joining me. I hope this presentation has provided you with valuable insights. So after this course, after this session, our counselor shall be sharing with you a detailed brochure. I request you to please go through it. It will give you a detailed view of the course content and the value you have. Also, there shall be a short feedback form where you may rate the session and ask queries which you have, and our team will get back to you. Thank you.